Hello friends, let us now learn some important points about production of X-rays. X-rays. X-rays are mainly produced whenever fast moving electrons, so this is the X-ray tube. Actually, whenever fast moving electrons, when they hit the target anode, then X-rays are produced. X-rays are produced when fast moving electrons from the cathode accelerate and they hit the anode, then X-rays are produced. So, X-ray tube is mainly made up of when fast moving electrons, when whenever fast moving electrons uh, are actually generated from cathode, when they hit the target, that is when after when the fast moving electrons hit the target, then the from the target the X-rays are produced. Okay, now this is the diagram of X-ray tube. So if you see, this X-ray tube is actually made up of Pyrex glass, and this X-ray tube encloses a cathode, which is tungsten filament, and an anode. When a high potential difference is applied between the cathode and the anode, then electrons are produced from the heated tungsten filament, and they will be accelerated across the tube and they hit the target anode. Then X-rays are produced. So, we have to learn about three important things in this lecture. One, we should learn about the glass enclosure. Second, we should learn about the cathode and anode. So, glass enclosure. This glass enclosure is very important to seal the two anodes of the X-ray tube in vacuum. In the beginning, previously, gas used to be present inside the X-ray tube. When gas is present inside the X-ray tube instead of anode, these electrons which will come from the whenever the electrons arise from the cathode, that is the tungsten filament, these electrons will collide with the gas molecules. When they collide with the gas molecules, the energy of this electron decreases. So as a result, on serial collision with different gas molecules, the energy decreases and the effective electrons which will hit the target will decrease. So as a result, X-rays are not satisfactorily produced. So the whole process might become uncontrolled. So, so as a result, the gas is removed from the X-ray tube, and now there are X-ray tubes are mainly produced with vacuum. So gas enclosure is mainly for in the inside the glass enclosure there are cathode, there is anode, and also both these are suspended in the vacuum. Then the size and shape of the X-ray tubes are designed to prevent the electric discharge between the electrodes. Then there are connecting wires. The cathode and anode are connected to the high potential difference. So there is connecting wires which connect the cathode and anode. The connecting wires must be sealed in the glass wall of the X-ray tube. So when we are going to operate this X-ray tube, both the glass wires, that is the uh, so here there is a space where the glass wires and the connecting wires must be sealed into the glass wall of the tube. So whenever the X-ray tube is operating, one problem with this X-ray tube is that the glass wire and also the glass tube and the wires are connected with each other. There is a difference in the coefficient of expansion between this glass and also the wires. So whenever there is coefficient of expansion is different, the metals will expand more when compared to the glass when they are heated. So this difference in expansion will cause breakage of the glass metal seal, and when there is a breakage in the glass metal seal, then uh, then the air will enter into the X-ray tube and that will cause the problems. So that is about glass enclosure. Next, after glass enclosure, we have to also learn about the next important thing that we have to learn about the copper anode. So this copper anode is a negative, sorry, copper anode and copper and cathode. First we will learn about cathode. This cathode is the negative terminal, whereas anode is the positive terminal. This cathode is also called as filament. This filament is actually the source of electron. So this filament is the one which will produce electrons. So these are the source of electrons. So whenever these are connected to a voltage of 10 volts and a current of 3 to 5 amperes, this will heat the filament. When the filament is heated, this will heat the filament. When the filament is heated, then the electrons will move towards the target and they hit the target. This is fine. So first, before we go about actual process that is occurring here, we should learn about the filament. Filament is actually made up of tungsten wire, and this tungsten wire has actually diameter of 0.2 mm, and it is coiled in a vertical spiral with a diameter of 0.2 centimeters in diameter, and the length, it is coiled in a vertical spiral of length less than 1 centimeter. So when the current flows through the tungsten wire, it becomes heated. So what happens when the current flows through the tungsten wire gets heated. So heat is nothing but the thermal energy. So when the current passes through the tungsten wire, it is heated. Heat is nothing but the thermal energy. So the atoms absorb the thermal energy. That means electrons will absorb the thermal energy. When the electrons absorb the thermal energy, they absorb energy enough to move a small distance from their metal surface. They cannot accelerate into the anode. They do not have the energy required to accelerate towards the anode, but they acquire energy by the heat in such a way that they can move a little distance from the surface of the metal. So this escape is referred to as thermionic emission. Carbonic emission is the emission of electrons after the absorption of thermal energy. So this absorption of thermal energy will result in electron cloud formation. So this electron cloud which is formed is called as Edison's effect. Now we have this filament is actually made up of tungsten. Tungsten has a melting point of 3370 degrees Celsius. So, pure tungsten, in order to for the electrons to get emitted, the pure tungsten should be heated to at least 2200 degrees Celsius. If the tungsten is heated to 2200 degrees Celsius, then electrons are released. Tungsten, because it has a higher melting point and it can be heated up to this temperature, we use tungsten. And one more reason for using tungsten is strong. Because it is strong and it can be drawn into a thin wire. Third reason for using tungsten is tungsten has long life expectancy. Now, the electrons which are emitted from the tungsten filament form a small cloud in the immediate vicinity of the filament. So this collection of negative charges or collection of electrons is called as phase charge effect. This collection of electrons is called as phase charge. So these electrons will are negative charges. If you see, cathode is also negative charges. So these electrons will prevent further more electrons from being emitted from this metal surface. So as a result, slowly this prevention of electrons from emission from the filament is called as phase charge effect. Phase charge is a negative charge, which are negative charge seen around the filament is phase charge, whereas phase charge effect is the extra electrons are being prevented from uh, coming out of the metal surface due to the negative charges charge of the cathode. This is called as space charge effect. Now, what actually happens is that when electron tries to leave the filament, there is loss of electron. So the filament will acquire the positive charges. So because of the positive charge, immediately one of the electron from the space charge is attracted by the filament. So what? So when the filament is heated, it emits electrons. Okay, one electron is emitted to this electron cloud. So the filament will acquire positive charge. So one more electron from the space charge will enter the filament. So as a result, equilibrium is maintained. But the electrons still they did not get enough energy to get accelerated towards the anode. Slowly, the filament is heated. As the filament is heated, the electrons will gain more and more energy. So at once they will get the energy to go towards the anode, to accelerate towards the anode and to hit the anode. So large number of electrons are accelerated from the cathode to the anode of the X-ray tube. So this emission of electrons is a lot. It is very lot. It is enormous. So if you see, this electric current will flow only from cathode to anode, that is in one direction only. So this emission of electrons will produce the X-ray tube current. Whenever the electrons will flow from the cathode to the anode, this will result in production of X-ray tube current of around 100 milliamperes. Okay. Now, see, if one important thing is that these electrons which will flow from cathode to anode, they can flow in different directions. But we don't want the cathode from the electrons to be flowing from in different directions. We want the electrons to be flown in one single direction. So for that, to prevent the electrons from flowing in different directions, we have developed a technique where we have put a focusing cup around the filament. So what is surrounding the filament? So we have designed a focusing cup which surrounds the filament. So this is focusing cup. So what does this focusing cup do? This focusing cup will is always maintained at the negative potential. So because focusing cup is maintained at the negative potential, the electrons which are formed here, they will be towards, actually what generally happens is that this electron is a negative charge, this electron is a negative charge, so they both will repel each other, and as a result, instead of electrons flowing in one direction, they start flowing in different directions. But our aim is to prevent this flow of electrons. These electrons start spreading from each other and they miss the target anode. So we do not want the electrons to miss the target anode. So for this, we have started this focusing cup. A focusing cup is placed around this cathode filament. So when a focusing cup is maintained at negative potential, this is maintained at negative potential, whereas this filament also has negative potential. So the negative charge of the filament and the focusing cup is kept the same. So when X-ray tube is connected to high potential, there is same negative potential is applied between the focusing cup and also the filament. So this focusing cup, so what happens is the filament electrons are released. So when the electrons are released, this focusing cup will, these electrons are being repelled by this focusing cup. So as a result, the electrons, instead of flowing away from each other, they started converging, and thus as a result, all of them are focused onto the metal anode, target anode. So the focusing cup is actually made up of nickel, and this focusing cup is designed so that the electrons will flow in a single proper stream, and so that these electrons are accelerated from cathode to anode in the required size and shape. Then followed by this, we have also developed double filament. See, in the focusing cup we can use single filament as we have already seen, or we can use double filaments. These double filaments are mainly these. In a double filament modern X-ray tube, we have single filament X-ray tubes and also double filament X-ray tubes. These double filament X-ray tubes have one important, application. These double filament X-ray tubes, we have two filaments which are mounted on each other side by side. So one filament is for small focal spot, whereas the other filament is for larger focal spots. Small focal spot is for smaller exposure. This large filament for larger focal spot is for larger exposure. So this will help us to alternate or use the filaments which is required for the sufficient amount of exposure. Next. Next, one more important thing after learning about the focusing cup, then we have to learn some of the important um, disadvantages or side effects or disadvantages of this tungsten filament. So one such disadvantage is that this filament is thin. So on heating the filament again and again, this filament will become thin and the filament might break. When the filament breaks, the when the filament breaks, the this will shorten the life of the X-ray tube. That is number one. The filament should not be heated for a longer periods. That is one. So you should prevent the filaments to be heated for longer periods. So how are we going to achieve this? So one thing that we can do is that when this is connected, when cathode and anode are connected to a high potential difference, immediately the filament gets heated. So when the filament is heated for a longer periods of time, the tungsten filament might become thin and it might break. So to prevent that, we have designed a standby circuit. So what is the standby circuit? In standby current, initially potential difference is applied between the cathode and anode. For that we use only a small amount of current is used, that is only 5 milliamperes is allowed to pass between cathode and anode. And this and here this is sufficient to heat the anode. Later when we are going to expose the patient, at that point we will make the exposure. So when the exposure is made at such particular point, large amount of potential difference and large amount of current is applied between cathode and anode, so that at once the exposure is made, only then the X-rays are produced. So initially when we switch on the X-ray machine, a small amount of current is applied between cathode and anode. Later, large amount of current sufficient to make exposure has been given. So in this way, we can prevent the tungsten to be exposed for longer exposure periods, and we can increase the short life of the X-ray tube. Next, the next one more important thing is that when tungsten is applied for a longer periods applied to current, or when the tungsten is exposed to current for a longer periods of time, then this tungsten might become vaporized. The tungsten from the filament might get vaporized, and this tungsten might get deposited onto the glass tube. When the tungsten is deposited onto the glass tube, the this produces a color, and this occurs as the tube ages. So these aging tubes will produce bronze colored sunburn over the glass envelope. This will produce two different effects. Number one, the X-rays which are going to oh, these X-rays which will go from which are produced at the anode, these get filtered at this tungsten bronze colored sunburn. That is one. Number two, that these tungstens are deposited over the glass, so the coefficient of expansion between this tungsten and glass envelope is different. So as a result, this will also gets the heating of this tungsten and deposition will also might also get breakage of this glass. So these are the disadvantages of heating the tungsten. So these are the important points about the cathode. So this is about the cathode. In the next class, we will learn about the anode. Thank you.